Up until this point, we've been talking about trig functions. So talking about how to graph them, how to transform them, all their reciprocals, and so on. Now we get into something a little bit different. 5.4 is on solving trig equations. Okay, so I've set up a warm-up on grade 10 and grade 11 material just to, review a little bit. Okay, so the grade 10 stuff, I'm not going to go over in too much depth. I'm going to go through it really quickly. What you're going to do is take this trinomial and break it up by factoring. Then you're going to solve each of the brackets and you get what y equals 2. So the whole point of solving is to be able to figure out what your variable equals to. All right, in this one, you're common factoring this x out. Okay, so they both have an x. And then you put all the leftovers in another bracket. And again, you're just solving each of the brackets. So that's grade 10 stuff. Now grade 11 stuff is where we start to introduce some trig functions in there. Now I want to know, when is cos x equal to 1/2? The graph cos x goes on and on forever. I mean, it goes on the left-hand side and the right-hand side forever. Okay, so you could have infinite number of answers where x allows you to have cos of that equals 1/2. Okay, so that's why they introduced this part right here. They're limiting your answer to a certain domain. I only want the answers from 0 to 2 pi. To answer this type of question, what you're going to do is you're going to make your triangles in the quadrant chart. Now, I'm not going to go over this in depth because I have other videos on it. You can watch the special triangles video, okay, and they'll tell you how to set up all of the triangles in the quadrant chart. But basically, you have a positive 1/2 and cos is positive in the fourth and the first quadrants. Okay, so I put my adjacent, which is 1, and 2, which is my hypotenuse. See, adjacent over hypotenuse. Same with the bottom triangle, adjacent over hypotenuse. And I recognize that this is one of the special triangles, so I filled in the rest of it. This looks like the scalene guy, and I put in my angles. Once I have those, I'm going to look at the domain and I'm going to say, okay, what are the answers for x within those domains? Okay, so from 0 to 2 pi, I'm going to go starting at standard position to the first terminal arm, that's the pi over 3. We already found that. The other one is if I go all the way around to 2 pi, but then I go backwards, pi over 3. So this is my calculation, and that equals to 5 pi over 3. So my answers within this domain are pi over 3 and 5 pi over 3. So just really quickly, the other one, notice that it has a different domain. We're going to 0 to 4 pi now. Okay, now sign is negative in this case, and that happens in quadrant 3 and quadrant 4. So I've set up my opposite over hypotenuse for both of them, opposite over hypotenuse, and I've also set up the angles. So from 0 to 2 pi, I have two answers. So these are starting from standard position to the first. Okay, so that's 1 pi plus a pi over 3. That's 4 pi over 3. And then the second one is going all the way around, but then backing up. So subtracting pi over 3, and that would be this guy right here. But that's only for 0 to 2 pi. That's only one rotation. We want to go to 4 pi, so I'm going to double it and go another rotation. So I get some more answers. Okay, so this one goes all the way 2 pi and an additional pi, and then an additional 1/3 of a pi. So when you add up all those guys together, you get 10 pi over 3. The second answer is going all the way around, that's 2 pi, one more pi, so that's 3 pi, and then another pi, that's 4 pi, but then going backwards to your terminal arm, so you got to subtract that 1/3, and that is 11 pi over 3. Okay, so 5.4, today's video is putting both of these two concepts, your grade 10 and grade 11 stuff, together into examples. Okay, so these are all of the different things that you have to keep in mind. I'm just going to pause this here so that you can click pause if you want to and just look at them. But basically what you want to do is isolate the trig function onto one side. Then you want to make sure that there's only one term for the function. Okay, you want to use cast rule, and then know that you're going to have multiple solutions. I'm going to show you some quadratic trig examples in a separate video. Okay, so we're only going to look at linear ones. Okay, so the first linear equation, that means no squares, okay, so no little 2's or exponents, is something like this. Now, I want to get rid of this 2, and I'm just going to bring it to the other side so that I get cos x by itself. Okay, so we're going to just divide by 2. We got something like this, and now it looks a lot like what we saw in the review. So I'm going to draw both of my triangles. I'm going to complete the triangle using any of my special triangles information. Okay, so now I know that the angles are pi over 6. All right, and then I'm going to answer the question for this domain, 0 to 2 pi. So the first one is starting from standard position, going all the way to pi, but then subtracting. So I got to go backwards to the terminal arm. All right, so that's my first answer, and that's going to be 5 pi over 6. Now my second answer is going from standard position all the way to the second one. Okay, so I go past pi, I'm going to add a pi over 6. So that together would be 7 pi over 6, and these two are the answers for this equation. Okay, let's try another example. This one is a little bit different. This is our last example for this video, and it is more complicated because there is this horizontal compression by a factor of a half. So what I want to do first is just try to visualize what this looks like. You don't have to write this on your paper if you don't want to, but this is just understanding what's going on. Okay, now a cos graph would normally look like this. Within a period of 2 pi, it would normally have gone one cycle. All right, but because you compressed it by a factor of 2, you basically can now you can put 2 cycles within that original period. All right, so you've compressed it. Now a normal period will be 1 pi. So how many times is this guy going to equal to 1/2? Well, I mean, this is 1 right here, right? So half would be somewhere around here, and it looks like it happens 1 time, 2 times, 3 times, and then also 4 times. So my goal is to figure out what are those x values along the x-axis where that happens. And just keeping in mind that I will have 4 solutions. All right, so that is over this domain. Now there's something additional. So here's the tricky part. What we're going to do is, because this has doubled the x, we're just going to take this domain and we're going to double it. Okay, so double the 0, double the 2 pi. So we get 4 pi. I'm going to show you, it's going to make a little bit more sense once I start to draw the triangles. Okay, so where is cos positive 1/2? Well, that happens in the first quadrant and in the fourth quadrant, and I've set up my special triangles, and I know this is a pi over 3. So we're just going to answer that part of the triangles first. Okay, so you got your 2 angles, you got your pi over 3, and this guy is going to be your, all the way to the end, 2 pi minus the pi over 3. That's my second answer. And I know that these two are my answers for just 2 pi. But I'm going to 4 pi. Okay, so let's introduce those orange arrows as well. Okay, going all the way around 2 pi, and then that additional pi over 3 gives you this calculation, which is 7 pi over 3. That other triangle to go, sorry, the other arrow that goes to the other triangle goes all the way around. So you got your 2 pi, and then also again 4 pi, but then subtracting that section, that pi over 3. So that is this calculation giving me 11 pi over 3. So what I've done so far is I've just shown you I'm calculating for 2x so far because it's within this domain. But the answer for the question originally asks for this domain. So what I'm going to do is I'm now just going to solve for x. How do you think I do that? Well, I want to get rid of that 2. So I'm going to divide by 2, and I get each of these guys divided by 2 just ends up doubling the base. Okay, so just scroll down a little bit. So whoops. There you go right there. Our final answer for the yellow domain is right at the bottom. These 4 right here. And again, we should expect 4 solutions. So this guy is this dot right here. This one is that dot right there. This one and this one are the last 2 dots right here and here. All right, so this is a video for just linear equations, solving trig equations. I'm going to do a separate video on the quadratic equations.